Hi, Algebra 1 students. This is Mr. A. As promised, I am going to take you through some of the examples on your notes page. And I'm not going to work out all the examples. I'm going to save some for you to do. But at least this way you have some examples that you can see working out in real time that you can duplicate on your notes. And sometimes you might even want to hit the pause button and stop the video so then you can try the example yourself and then come back and hit it play again and see if you're right or if you need to make any changes or whatever. So without further ado, let's go ahead and get going here. The next topic in our Algebra 1 world is about how to factor polynomials. Now, in the last topic, we learned how to add and subtract and multiply them. And instead of dividing, we are going to do some dividing in this topic, but instead of calling it dividing, we call it factoring. And basically, factoring a polynomial undoes multiplying a polynomial. So we have several techniques here that we're going to use to factor polynomials. And then at the very end of the topic, we're going to combine two or more of these techniques together in some cases and factor polynomials completely. And that means that all the terms that we receive, all the factors that we receive, don't have any GCFs or greatest common factors larger than 1. So we have several techniques to go over. I'm going to start out here. The first technique we always talk about is how to factor using the GCF, or the greatest common factor. So in order to do that, we're going to first of all do this little fire up, for like a better term, question here that I would usually just toss you guys and let you guys figure it out on your own for a little bit. Since we don't have the option of doing that, I'm just going to take you right through it. So there you go. The only thing different about this problem here is that we have included some variables into the terms, and it really doesn't make the problem that more difficult once you know how to handle the variables. So here's what we're going to do. Okay, we're going to take a look here at this problem. And if you notice right here, I have a hint. It says use prime factors. So what we're going to do is we're going to break down 20 and 24 using a factor tree just real fast. I'll just switch over here and use blue here for 20. And remember, 20 is 4 times 5. Those aren't prime. So 5 is prime, so we're going to leave that at 5. But we'll change 4 to 2 and 2, like so. So when it says use prime factors, what we're going to do is we're going to rewrite 20 as 2 times 2 times 5. Okay, and then we're going to do the same thing over here for 24. And we're going to break down again. And I'm going to use 6 and 4 this time. Neither of those are prime, so I'm going to split them up again. So this is 2 and 3 and 2 and 2. And this then comes 2 times 2 times 2 times 3. Now, to take care of the variables, all we're going to do is we're going to just expand those out. We talked about expansion a lot in the exponents unit. And all we're going to do is write x times x times x for x cubed for the first term. So we're going to do times x times x times x. And then 2y's times y times y. And then for the second term, we have 1x. So we're going to multiply that by an x. And then we're going to multiply by 4y. So y times y times y times y. Now, to get the GCF, all we have to do here is circle the common factors from the two terms. So we have a 2. We're going to circle that. And we have another 2. So we're going to circle that. And then I see we have an x that's in common. And it looks like we have 2 y's that are in common, 1 and 2. So we're going to multiply all those together. So we're going to have 2 times x times y times y. Now if I multiply all those together, I get a GCF of 4xy squared. And that's going to be the GCF. Let me fix that fill. I don't want that fill on there. So give me just a second here to get that fill taken care of. There we go. All right, so now you're going to try this next example and try to find the GCF of these two terms, the same way we just did right up here. So let me put out another problem here for you. And if this would be a good time here to start to hit the pause button, maybe give this a try. So I'll give you a second to hit the pause button. before I keep talking and I'll go through the problem with you. Okay, so here's how we're going to work this one. I'm not going to do the factor trees for this one now. Well, actually, I think I will, because these have a lot more factors in them, and I need to remember what they are myself. So we're going to break up part 36 here, and I would just do 6 and 6, make it real easily. And that's going to be 2 and 3 and 2 and 3. And then for 48, let's see, let's do, I don't know, let's do 12 and, or let's do 6 and 8. That's good. Let's just do 6 and 8. Now, a little trick with 8. 8, I just always split up by 3 2s, 2 times 2 times 2. That way it's already done, and then we'll have 2 and 3 there. All right? So, let's go ahead and write these down. So we have 2 times 2 times 3 times 3. And then let's do 2 times 3. Oh, I'm sorry, erase that 3. We'll do the other 2's first. I like to do a numerical order. Makes it a little bit easier to find common factors. So 2 times 2 times 2 times 2 times 3. Now, let's go ahead and circle these. Because I have a little trick to show you how to do the variables in a minute. That's going to make it a lot easier. So we'll circle the 2's and another set of 2's and a set of 3's. So we're going to have 2 times 2 times 3. That equals 12. Now, a little trick for the variables that you can use exclusively to this recording. So if you follow this recording, you get a little bit of heads-up knowledge that everybody might not get. So that's a little bonus for listening to me and putting up with me here. Let's go back for a second. I want to show you a little trick here. Did you notice that we have x to the third and x on the two terms on the previous problem, and the GCF was the x, or just one x to the first power. Also notice that for the y's, we had y squared and y to the fourth, and the GCF factor was y squared. In each case, the GCF factor was on the variable was the variable's smallest power. Okay, because if you look, for example, the x's, they each share 1, right? But no more than 1. So it's the smallest power on x. And likewise, on the y's, they each share 2, but no more. So it's the 2 on x. And excuse my dog, as he is going crazy at the moment, barking at something outside. All right, so let's go back to our problem here and take a look. On x, we see the smallest power is 4. On y, it is 2, and on z, it is 2. So now real fast, I can finish this GCF. So it's going to be 12 x to the fourth, y squared, z squared. And that is my GCF. Okay? So, now I'm going to give you one to try here. Then we're going to do it with 3 terms. So here's one for you to try real fast. It's a good time for you to hit the pause button. And when you're done, I will unpause it, and I will take you through how to find the GCF real quick, because now we're going to use this to do another step. Okay, so for 30x squared, we have 2 times 3 times 5. For 24x to the 6th y to the third. We already did 24, so that one shouldn't be too difficult. It's 2 times 2 times 2 times 3. And then for 28, it is 2 times 2 times 7. So if we're looking for GCFs, we're going to circle the 2's because they're in common, and I believe that's the only common factor we have with the numbers. So our GCF is going to be a 2, and then look at your variables. Looks like the smallest power on x is 4, and the smallest power on y is 1. So we're going to have 2x to the fourth y for our GCF. And if we could continue to go here for just a minute, I want you guys now real quick to hit the pause button and multiply these together, these two terms. I want you to multiply this binomial right here, this 2x to the fourth y, by each term in the trinomial. Okay, I'll give you a second pause and try that real fast, and I'll show you how to do it. Okay, so if you do this, then what happens is that you get 30 x to the fourth y squared. I'm going to change these other arrows to red and green. So we have red and green. And so 2x to the fourth y times 12x squared y squared becomes plus 24 x to the sixth y to the third. And then 2 times 14, 2x squared 4 to the 2x to the fourth y times 14x to the fourth becomes plus 28 x to the eighth y. Now, if you can check this out real fast, I'm going to pull this back down here real fast. Notice that the terms match. For example, let me show you here what I'm talking about. We have a 30x to the fourth y squared here. We have one right here. We have a 24th x to the sixth y to the third there, and we have one right there. And we have 28x to the eighth y to the first there, and we have one right there. So what actually we did was we factored our original expression. We added up all those terms together. How do we do it? We take each of the terms and we divide them by the GCF, the greatest common factor of all three. So here's how this end result here compares to the previous problem. It's all three terms added together to form a trinomial, and then the product here that we just multiplied right here at the very top of the screen is the factored form of that polynomial. So we just actually factored a polynomial using the GCF. So in conclusion, okay, the factored form of this polynomial is the GCF times what's ever left over. And we know that the GCF is the value 2x to the fourth y. Now, if we want to find the GCF, I'm going to move this up one level here just real fast. Because what I'm going to do now is I'm going to divide each one of these terms by 2, like so, okay, to get the values in the second group. And not only 2, but 2x to the fourth y. I'm going to divide them by the GCF. Okay, so when you do this, you will have 2x to the fourth y. Let's change that color to purple since everything else is purple there. Change it real fast, and then we'll put the other factor in orange here just to kind of just differentiate it here a little bit. 30 divided by 2 is 15. Okay, the x's cancel out. 4 minus 4 is 0. 2 minus 1 is 1, so I'll have 15y. Okay, and then for the next term, I'll have 24 divided by 2, which is 12. And x to the sixth divided by x to the fourth is going to be x squared, 6 minus 4. And then again, 3 minus 1 is going to be y squared. And then 28 divided by 2 in the last term is 14. X to the eighth divided by x to the fourth, x to the fourth. And then y minus y, that cancels out. That, ladies and gentlemen, is the factored form of this polynomial. So that is our first factoring technique. We're going to factor by the GCF. This is a very common technique. It's used quite a lot. We always check for a GCF first. That means if all the terms have a GCF, they share a GCF, then we always try to factor it out first and then see if anything from the resulting expression factors out. So here are the steps, as you can see on your notes, on how to factor a polynomial by the GCF. You find the GCF of all terms, number 1. Okay, you divide each term by the GCF, number 2, and then you write the answer in factored form. And you always put the GCF out in front. Okay, and of course you have that in your notes, so I'm not going to take that long to go over it with you. All right. Now, to factor each expression, we're going to just do a couple of examples here. I'll work the first one and the second one, and then I'm going to leave, let's see, I'm going to leave the third one for you to do on your own. That way you'll have a little bit of time to do one. So for the first one up here, we're just going to find the GCF of each of the terms. Okay, and we're going to do it just like we've been doing it. So we're going to do the GCF, okay? And I'm not going to take the time to find it this time. I'm going to let you guys do it on your own. I'm just going to tell you that I can tell by looking at the numbers that the GCF of the numbers is 6. Okay, they both have the biggest factor is 6. Then looking at the variables, I can see that's going to be 6 x to the 5th, and then y the second, because 5 is the smallest exponent on x, and 2 is the smallest exponent on y. All right, so if I divide each one of those terms by 6x to the 5th y squared, then the factored form becomes the following. We'll put the GCF down here. So it becomes 6x to the 5th y squared as a GCF. Then when I divide by those, 18 divided by 6 will be a 3 left over. 5 minus 5, the x's cancel. And ironically, the y's also canceled. So those are going to be gone. So this is going to be 3 in the first term left over. We're going to subtract that then, because the sign between them is minus. 24 divided by 6 is 4. X to the 6th divided by x to the 5th is just an x. 3 minus 2 is just a y. So this is factored form of this polynomial. And again, and one of the other things we're going to really emphasize here on this is that it's very, very interesting to check your work. This is very easy to do so, because all you have to check your work is just multiply your factors back together again. So if you multiply this, the distribution, and distribute this to this term, you will get 18x to the 5th y squared minus 24x to the 6th y to the 3rd. So this, ladies and gentlemen, is the final factorization. Okay? Perfect. Let's go on to number 2. Okay, now on number 2, we have 48x to the 6th minus 32x to the 4th plus 40x squared. Go ahead and hit pause and try to figure out the GCF on your own, and then I'll help you with the second step. Okay, so if you found the GCF on your own, you should have figured out that the GCF is, looking at my numbers here, it looks like I'm going to have 8 for the GCF of the numbers. And then the smallest exponent on x is x squared. So when I go to find the GCF, I'm going to divide each term by 8x squared. And if you notice, I'm going to keep the signs on the terms as they currently are. Okay? So, all right. So here we go. We're going to have 8x squared, and then divide each one of the terms by 8x squared. I'll pause for a second and let you catch up with me. Okay, so when I divide these, 48 divided by 8 is 6. And I have 6 minus 2, which is going to be x to the 4th. And then on the second term, it's going to be minus, and that's become 4. It's going to be x to the 2nd. 4 minus 2 is 2. And then for the last term, it's going to be plus 5, because the x's cancel out. The x squares will cancel. So the final factorization of this one, 8x squared times the quantity 6x to the 4th minus 4x squared plus 5. So that's how you factor expressions and with the GCF. So I'm going to leave you to do problem number 3, and I'm going to stop this video, and we'll make another video for the next topic, because I just realized that these are going to be a bit longer than I thought. So we're going to just do it by segment. That way it'll be easier to reference. All right, so I'll stop this one, and I'll start another one as soon as I can.